Okay, so next up is law of cosines. And so that was for side angle side and side side side. And law of cosines, there's three forms of it. It's in the notes. I'll actually write the sort of basic form as I'm doing the problem. So this first one is side angle side. So we're going to know A equals 2, B equals 3, and C equals 60. And so we're looking for two angles, one side, and this one. And law of cosines, at least one form of it, is c squared equals a squared plus b squared minus 2ab times cosine of c. And so then there's three forms, one with a squared over here, one with b squared over here, and one with c squared over here. They're all basically the same thing. You can look them up on the sheet. Like I said, you get a sheet of notes, the formula sheet with the test, which I still need to post up. So we got this, and we have A, we have B, we don't have C, that's cool, we can get that, and we have the angle C. So we want to make sure if we have side angle side, we're not going to know the opposite side of the angle, so then this is going to get that for us. So pretty much we just plug stuff in, and this one doesn't have an ambiguous case, so it's easier than law of sines. And then kind of grind out all his math with it. So this would be 4 and 9 is 13. Minus 4 times 3, 12. Cosine is 60. And then from there, actually I put it in a calculator, but it comes out nice. It comes out to 7. And then root both sides, and then C equals root 7. So that got us our third side, and now we need to find the other two angles. So I could use law of sines to do this, but that has that ambiguous case, so that's not that attractive. So instead what I'm going to do is use law of cosines, this time for a squared. So that one goes a squared equals b squared plus c squared minus 2bc. So it's just the other letters, and then cosine a. And what I'm trying to solve for is cosine a, so what I will do is I'm going to bring over, I'm actually going to bring, because I don't like this minus sign, so I'm going to bring a squared this way, and I'm going to bring this whole chunk over here. So I'm going to bring this over and have it be a positive. And then I'm going to subtract the a squared over. And then I'll divide both sides by 2bc. And so what that does is gives me cosine a. And so now I can plug in all my a's, b's, and c's and get cos a. So that's going to be b was 3, c is, and I might as well just, I guess I'll put it in as root 7 to be consistent. And then a was 2 over bc. And that's 3 times root 7. And so then I think I put all that in the calculator, and that got me about 0.7559. And then I did inverse cosine, because I know the ratio, so I need the angle. And then that gave me A as about 40.9. And then now that I know two of the angles, I can just do 180 minus 40.9 minus the 60. And that will give me, I have A, so this is B. And if you do that out, we get 79.1 degrees for B. Okay, so this is side, side, side. And so we have A, B, and C, and we're looking for angles. So I'm just going to arbitrarily pick A squared. I'm going to solve for A first. but again, that's arbitrary. So I need to solve for cosine A. So that's that same math I did in the last problem towards the end. So I'm going to bring the A over, and I'm going to bring this over. Okay. So 2bc cos A equals b squared plus c squared minus a squared, and then divide over the bc, or 2bc. Okay, so once we do that, then I can plug in a, b, and c, and that's going to give me the cosine of a. So 3 squared plus 6 squared minus 4 squared over 2 times 3 times 6. And then chunking all of that into a calculator. And actually, I think I turned it into an exact value. So I did the 9 and 36 minus 16 and got 29, and 6 times 6 is 36. Since it was easy enough to get an exact value on this one, there was no root. So then I can do cosine, inverse cosine of 29/36 is going to make a. And then when I put that in the calculator, I get a equals 36.3 degrees. Go on to another piece here. And so then I did the exact same solve and came up with cosine b equals a squared plus c squared minus b squared over 2ac. Same steps as last time though. And then let's see, a was 4, c was 6, and b was 3. So that's over 2ac, so 4 times 6. And let's cos b. And then here, again, I squared these, took away this. I ended up at 43 over 48. So you can do inverse cosine of 43/48, and that will give me b, and I got that to be about 26.4 degrees. And then once I have that, so I can do the 180 minus 26.4, and then a was 36.3, and that will leave me c, and then c comes out 117.3 degrees.